If you have listened closely to what we have discussed so far, now you would have a clear-cut idea about what aspects of a programming language are most important when programming a game. So, without further ado, let's delve into the comparison of these features with Java and C#. To start off with, let's get back to the floating point support. Java provides you with extensive support for floating point variables using the keyword strict_fp, which provides you with precise floating point value allocations, whereas C# uses a higher standard floating point precision mechanism with 1 to 8 bits or higher to gain accurate floating point values. Next, let's go back to dynamic memory allocation. When it comes to dynamic memory allocation, Java and C# both provide excellent mechanisms for dynamic memory allocation. The key difference being Java not using pointers, whereas Java considers pointers unsafe. C# provides great support for pointers when it's necessary by using the unsafe keyword and other mechanisms to trigger pointers to work. When it comes to graphics or GPU programming, Java and C# both have excellent APIs they can access in order to create great games. First of all, let's discuss about Java. When it comes to the JMonkey framework, which is an extensive Java-based game development framework, it has excellent support for 3D APIs and also 2D graphics APIs such as OpenGL and OpenAL for sound. And when it comes to XNA 3.0, it also provides you the same support for both DirectX and OpenGL graphics. When it comes to garbage collection, Java and C# both provide extensive support for garbage collection. In Java, you have efficient garbage collection within the programming language itself, where the programmer needs to handle the dispose patterns and other efficient coding to make sure that all objects are properly disposed. Whereas in C#, it also has an efficient garbage collection mechanism, although the XNA 3.0 framework has a built-in dispose pattern implementation which is very efficient and which every object inherits in order to make sure that all your objects are correctly disposed and made sure that they are not used afterwards. Like we have discussed before, referencing methods has to be very fast and very efficient in order to make sure that the events are triggered rightly at the correct time without any delay. In order to achieve this, both Java and C# have their own calling interfaces that use C++ techniques. The native C++ code enables the user to fastly execute any amount of methods in rapid succession. Java is a little faster than C#, although it's rumored that newer versions of C# support referencing dynamic objects while they are moving in and out of memory. When it comes to data types, as you can see in the narrowed down table, both Java and C# have most identical features when it comes to supporting the primitive data types. Signed integers, for example, are both the same in Java and C#. When it comes to unsigned integers, Java has only 16 character integers, which is not so good since integers and float point values are very essential in game development. And as you can see, according to the IEEE floating type standards, both Java and C# are currently following the standards. When it comes to large decimal support, you can see that C# has a built-in language support on large decimals, whereas Java has to use a first-party library to access its large decimal functions. When it comes to other features such as strings, which are more important in writing quality code, you can see that C#'s restriction on having fixed length strings at its language level doesn't make much harm since you can write quality code with the fixed length strings, whereas Java, although you can do it, it has a slight restriction of not having fixed length strings, which really doesn't matter. In contrast, both Java and C# also support providing you with custom data types, which is a very good feature when it comes to building your own objects and handling your code very efficiently and increasing your maintainability. And now we are here to demonstrate a rather cool yet closely related program using the JMonkey engine, which is using the NetBeans IDE that we have done here. The program is basically an online role-playing game that we are trying to perform on the same client, and as you can see, JMonkey, although it provides you with greater and extensive methods with IDEs, it does have certain problems when it comes to rendering. Although the support is extensive, you can see that the game has slight glitches when you move around and things like that. The basics of trying to make a game is not really simple to be explained through a video, so we thought it wise that you see how a code is executed generally by the normal debuggers such as NetBeans IDE 6.7 that we have used here. And since we are not really skilled at XNA developing when it comes to game development, we don't have any source code to present to you, but still we downloaded some source code from Microsoft and Xdream, and we compiled it, and we have the program to show you in order to make sure that you don't get the wrong impression about XNA, since it's a great platform to run games on, although it is a new platform, an emerging one for both PC and Xbox. I hope you enjoy this video. Now we come to the conclusion of our video. I hope you learned something out of this video, and it is really interesting if you are sort of into game development, and it was a new experience learning about XNA for us also, because we were rather familiar with JMonkey, but now we are having certain ideas that XNA also might be the platform under which we can develop games further. And although it's wise that you learn about new technologies, it's still better to stick to the old one, since XNA still doesn't have a greater support for its game development. So as a tribute to the JMonkey engine, we would finally like to show you this video and end our presentation. Thank you everyone.